Welcome to Differential Equations, Chapter 2, Section 5. In this section, we will be learning about different stabilities of differential equations. So in this case, you're going to be able to find the slope field with each function, and it might have multiple stabilities, might have multiple instabilities, or a combination of them. This section is actually really simple just because you look at the graph and see if it's converging or diverging to a point. We also have a semi-stable, but we'll get to that in a bit. So whenever one solution is it's converging, we call that stable. So like this solution is going to this value. That's why we have the line there. So we can say that this is stable because both sides of the solution are actually converging. Now if we go over to this one, we notice that these are actually going away from each other, or going away from the line, so we call that unstable. And lastly, we can have a semi-stable case. That means that this one side is converging to this line, and then this solution is actually diverging from it, so we call that semi-stable. We also have a couple other terms like let me check here 1 second. We have, logistic growth. That's just always a function that looks like this. So we'll have derivative y with respect to t is some rate of 1 minus logistic growth y over k times y. And then we also I believe they were talking about critical points as well. So critical points are when the function has derivative of 0. So just make sure to label these critical points. So if this was like the y-axis, we could say this is like x is equal to 4. So with their last example, if this was the actually we'll go up top here. If this was the maximum velocity for that falling object that we had in section 1.1, I believe, this would be what the graph would look like. And we can say this critical point is the maximum velocity. So that was when dv dt is equal to 0, and we can find out which line that is, and all solutions will converge to that value.